squared plus mg h plus c.
1 half mv squared is the kinetic energy. The rest of it is the potential energy, MPH, plus a constant if you want to throw that in. All right, so this has more mass. Matter of fact, the center of mass is farther away from the ground, or whatever we're going to use as a reference to the table. This one will have more potential energy. It has more potential energy to start and more kinetic energy at the bottom. However, it starts out with all this gravitational potential energy. As it goes down, that potential energy is getting converted into kinetic. Well, some of that kinetic gets into getting it to roll. Other parts of the kinetic get it into actually moving down the ramp. So we got the speed down the ramp, and then we got the rotation also. Both of them are going on.
You said potential energy turns into kinetic energy
Yes,
as it goes down.
in this case it does.
Okay.
We could have the reverse also happen. If I throw something into the air, the kinetic energy gets converted into potential.
Okay.
So as this rolls down, I'm converting kinetic into potential. And the question is, I start out with more here, I end up with more, but it's the same percentage. I'm going to lose just as much as converted into kinetic energy to make it go down the ramp for this as this. So if, I'm going to make up numbers here, if 50% of the potential energy gets converted into linear kinetic, well, 50% of this gets converted into linear kinetic. And ultimately, that leads to the same speed. The larger this number is, the higher the percentage that gets it into rolling, and less is left over to get it to go down the ramp. I've got $100 and I can spend it into getting something to move down the ramp or get it into rolling. The more I spend on getting it to roll, the less I have to get it to actually move down the ramp. So it's going to be slower. So the smaller this number is, the less effort it takes to get it to roll, and more is left over to get it to move down the ramp. Questions to hear? That's moment of inertia, that's connected with kinetic. I want to throw stuff down. Sling stuff, not throw, sling. There's a bunch of topics in chapter 8. It's just another one. What I'm going to do, so I'm going to take this and I'm going to swing it around my head and then I'm going to let go. What I want to do is we'll make that a bullseye. I want to hit that spot right there. I'm going to stand here in front of Gillette. And yeah, I'll do this here. All right. As I swing it around, the spot I want to hit is right behind you. The question is, where do I let go in order to hit it? That's the spot I want to hit. I'm standing basically right there, swinging it around in a counterclockwise direction from overhead.
I'm guessing the furthest point, like.
So here?
Yeah.
All right, well, just for the sake of communicating, we'll just call that 6 o'clock.
Oh, 6 o'clock.
All right, so we have a vote for 6 o'clock. Now, I will say that when I do this, I have never hit a student doing this, but not out there. I was doing something very similar to this when last time I taught middle school, hopefully the last time I ever teach middle school. And I got closer to hitting Scott than I intended. I got closer to Scott. However, I did not hit Scott. Scott's reaction when it came, it was about that far away, and it should have been farther. Scott's reaction was, whoa! Last period, that was first period, last period comes around. Student comes in and says, Dr. Fox, I heard you hit Scott this morning. No, I did not hit Scott. We'll clear people out of the way before I hit people. All right, so 6 o'clock, anyone else with another, so that is, I'm gonna release it when it's right here. Anyone else?
Other way.
Over here? Okay. So we got a 3 o'clock and a 9 o'clock then. So there's a vote for 9 o'clock, a vote for 3 o'clock. Another vote for 3.
3.
Also 3?
7.
Anyone else want to throw their hat in the ring? All right, I am going to ask if people sitting here would move over there in the room. Thankfully, no one went with 301. I'm not that coordinated to differentiate between 3 and 301. All right, so let's release at, it was the 9 o'clock, so that would be here. Three, two, one. It did not go towards the board. Let's try 7 o'clock, so that's 6, 7 is about here. I'm gonna try to go slowly enough. Jasmine, I suspect you're okay. Monica, is there anything in there that's you don't want spilled? If you haven't guessed,
That's
I'll
right.
figure out where I could. There you go. All right, let me go slower so it's not gonna zing someone. 3, 2, 1, go. Six o'clock. That's over here. Try to do it slowly. 3, 2, 1, go.
Good catch.
Still have a record of not hitting a student. Sorry about that. And then we're at 3 o'clock. So I'm now here. I have to do it slowly enough so I have some control. So 3, 2, 1, go. I released a little bit too early. So what is the path it takes once I release it? You can return. In which direction does it go when I let go?
And then,
It continues going same way, just -4.
Continues going the same
Well,
way.
counterclockwise.
Oh, so you're saying if I'm spinning around like that and I release it here, it's gonna be doing that?
Yeah.
I don't think it did that, because when I release it at 6 o'clock, or actually slightly before, that pretty much went that way. It didn't seem to curve away from Leslie. What is Newton's first law of motion? Newton's first law of motion. We could tackle it from the second law, but let's hope the first law would be easier.
Object that rests will remain at rest. An object that rests will remain at rest.
Okay, and the other part of it?
object of motion will stay in motion.
Doing what?
The object in motion will remain in motion.
Yeah, doing what?
What do you mean doing? Like,
I mean, motion, moving around, I mean, Earth's going around the sun. I mean, so we got motion going on there. But it's Newton's first, when, if you think back to the inertia girl story, why did my wife and I both call our daughter inertia girl?
cause you just kept
But it
on
stays still.
going.
It wouldn't, it's not a matter, not always just kept going and going, because when she was at rest, you wanted to stay at rest.
Once it starts, it doesn't stop unless there's a outside force.
It's not a matter of not stopping, it will maintain its velocity, it will stay the same speed and direction, and if it doesn't, then there's gotta be some force causing it to change. So when I let go of it, what are the forces acting on it after I've let go?
Gravity.
Then pick the force.
Normal force?
No,
Oh, wait.
you were closer. What is the force associated with gravity? Again, gravity, huge topic. We're looking at a tiny little part of it.
Earth.
You seem to get farther and farther away. Read my mind. Jennifer, did you have? It's something force due to gravity or weight. In which direction is the weight acting on the stopper? Yeah, by definition of what down is. All right, so it's acting down. So when I release it, it should travel in a straight line unless there's some other force acting on it. Since that force is down, it does go down. But there's no forces acting on it off to the side. So once I release it, it should just go in a straight line. Well, curve downwards because of the force of gravity. If I release it here, it should go tangent to the path. When I release it here, it should go that way. Release it there, it should go that way. There it should go that way. There it should go that way. I probably need to release it somewhere around 2 o'clock. So an object's going to keep going. If, however, it doesn't travel in a straight line, let's go with what Irwin had said. If it does not travel in a straight line, what can we conclude? What keeps something from going in a straight line at a constant velocity?
Some unknown force.
Yeah, some force, whether it's known or not. So since it will travel in a straight line, once I release it, obviously, traveling in a curve like that, it's not a straight line. There's got to be some force keeping it from going in a straight line. Somewhat quoting Godfather 3, Al Pacino's character. Every time it tries to get out, something just pulls it right back in. Instead of going straight, it's being pulled towards the center. So there's something that's pulling in towards the center to keep it from traveling in a straight line. That force is going to be some combination of the ones we've already done. But we're going to lump them all together as a general category, the force that pulls towards the center. The Latin translation is center seeking. It is centripetal. In the case of my swinging that around, it was the tension pulling it towards the center. As I was swinging it, the tension was the centripetal force. Why does the Earth go around the sun? Well, it's the gravitational pull from the sun, which is acting as the centripetal force. It is not that other word that is used more often. That other word, I will present it, and then potentially we will never speak of it again. What is the other word? That's similar to centripetal, but is not. Not that I could hear them because of my tinnitus, but just imagining crickets chirping right now. So in, I generally say in biology, you stick a test tube in the thing and you get it to whirl around. What is that called?
Centrifuge?
And yes. What is the name of the force that is similar to this, but not exactly? Oh, centrifugal. Or sometimes pronounced centrifugal, and that's sometimes pronounced centripetal, just because it's easier to emphasize the difference, and also I think what's American versus British pronunciation. All right. There are a number of things that are called centrifugal force. You're going in a car going around a curve, you see, it feels like you're being thrown to the outside. In reality, your body just wants to go straight. If you're in a car going around a curve, your body wants to go straight. So from your point of view, it looks like you're being pulled to the outside, but in reality, hopefully, you are not being pulled. You are actually being pulled in the circle, otherwise you're rolling out of the car. Centra meaning center, fugal meaning fleeing, away from the center. So centripetal, you're heading, looking towards the center. Here, you're going away. Quick vocab here. What is another English word, which, English as in our language, not British. What is another English word that has F-U-G, meaning to flee?
Fugitive.
Yep. What is another word we have in English that has P-E-T, that means coming together? This one's harder, but you all know the word.
PET coming together. No.
If you have two teams coming together, you have competition. Competition is a word, and I suspect petition also.
No, petition. That makes sense. Okay.
So potentially, this is the last time we ever mentioned it. There are some textbooks will say centrifugal is not a real force. I understand what they mean. It is not really a force, it's a perception. Some will refer to it as a false force. I will say that 99.9% of the time, whenever anyone uses this word, they're using it wrong. So potentially, never again is this force.
But we will use centripetal.
Yes, we will use centrifugal.
Centripetal.
Or centripetal. Centripetal just flows better for me, but
It does.